In this video, we're going to use some conversion factors to let us convert from polar to rectangular. Let's just go ahead and let's look at our triangle that's in standard position. It's y, r, and theta. So x over r was cosine, and y over r was sine. That means that x is equal to r cosine of theta, and y is equal to r sine of theta. So that's what we're going to be using here. So for our first one, x is going to be 5 cosine of 2 pi over 3. Y is going to be 5 sine of 2 pi over 3. 2 pi over 3 is 120 degrees. We have a 60-degree reference angle in quadrant 2. So this is root 3, negative 1, and 2. X is 5 times negative 1/2 is a negative 5/2. Y is 5 times root 3 over 2 is 5 root 3 over 2. So my rectangular XY ordered pair is negative 5/2, 5 root 3 over 2. X is going to be r cosine 2 pi over 3 again. Y is going to be r sine 2 pi over 3. X is going to be negative 7 times a negative 1/2 is going to be a positive 7/2. Y is going to be a negative 7 times a positive root 3 over 2 is a negative 7 root 3 over 2. R is for rectangular. Number 21, x equals r cosine of theta. Y is equal to r sine of theta. X equals a negative 3 times a negative root 2 over 2 is a positive 3 root 2 over 2. Y is equal to a negative 3 times a positive root 2 over 2 is a negative 3 root 2 over 2. Number 22, x is equal to 7 cosine 3 pi over 4. Y is equal to 7 sine 3 pi over 4. A negative 7 root 2 over 2. And that's 7 root 2 over 2. Go ahead and clear the canvas here. Scroll down a little bit. We've just got a few more. Number 23, x is 5 cosine negative 4 pi over 3. Y is 5 sine of 4 pi over 3. So it's a negative. So a negative 4 pi over 3 is going to put me in quadrant 2. X is equal to 5 times a negative 1/2. This is 5 times root 3 over 2. X is a negative 5/2, and y is 5 root 3 over 2. For number 24, 120 degrees. Same place in quadrant 2. X is equal to negative 7 cosine 120 degrees. Y is equal to negative 7 sine of 120 degrees. X is a negative 7 times a negative 1/2 is a positive 7/2. Y is a negative 7 times a positive root 3 over 2 is a negative 7 root 3 over 2. Negative 135 degrees is a 45-degree reference angle in quadrant 3. And then I'm going to be going negative 3, so I'm going to end up back in quadrant 1. But let's go ahead and figure this out here. X equals negative 3 cosine of negative 135. Y is equal to negative 3 sine of negative 135. If I don't want to deal with the negative angle, I can use my even-odd identities, like so. And then x is going to be equal to negative 3 times, and then cosine is going to be negative here, and sine is going to be positive there. X is going to be positive 3 root 2 over 2. And y is also going to be a positive 3 root 2 over 2. Just like we said, that puts us in quadrant 1. Last one here, if I go 270 degrees, I'm looking at, but I walk backwards, I'm at 90 degrees. So I'm up here at the point 0, 3. Let's go ahead and figure that out with x equals r cosine theta, y equals r sine theta. We're looking on the unit circle here at 270 degrees. We're at 0, negative 1. So the cosine of 270 degrees is 0. The sine of 270 degrees is a negative 1. So x equals 0, y equals positive 3. I'm at the rectangular point 0, 3. All right, that's it for this video. Next time we're going to come back and we're going to go from rectangular to polar.